depth first search, we've seen already. We've seen it in the context of solving for a maze. In depth first search, you start at a vertex, you visit it, then you choose one of the adjacent vertices to visit that, and then you choose some path to go down from that, and so on and so forth until you get to a dead end, and then you back up from there. Right, so we've seen that already. Here's an example of how that would work, starting from 0. Right, so we mark 0 as identified. Again, these are all sets that we're just manipulating. And now we choose a branch. We're going to go from 4. Let's go ahead and say choose an adjacent vertex that's not visited. So we've got 1, 2, and 4. I'm going to break any ties by just going with numeric order. Well, actually, we've got 1, 2, 3, and 4. So we're going to go visit 1 next. So where can I go from 1? Well, I could go to 0, but I've seen that. But I haven't seen 3 or 4, so I'm going to go see 3 first. Then from 3, well, I've seen all my adjacent. I've seen 0, I've seen 1, but I haven't seen 4, so I'm going to go visit 4. 4, I'm at a dead end. I can't visit anything from there. So I mark that as done, as finished, and then I back up to 3. And 3 says, hey, I'm at a dead end. I can't go anywhere, so I back up to 1. And then I mark that as visited, and then back up to 0. And so 0, though, I'm not at a dead end, right? I can still visit node 2, and from node 2 I can visit 5, and from 5 I can visit 6. And then 6 will say I'm at a dead end, so I've got to back up to from 6 to 5, and then 5 to 2, and then from 2 to 0. And then 0, there's nothing else to visit, so we mark it as done. So we've got 0, 1, 2, so we visited 0, 1, 3, 4, and then we visited 2, and then 5, and 6. That's the order in which we discovered nodes, in which we followed corridors down. And then we've got our finish order. So in other words, the order in which we hit a dead end. So discovery order is the order in which we discovered things. The finish order is in the order which we hit dead ends. We've got this concept called back edges, which connect a vertice to its ancestors in a depth first tree, right? So the idea here is that we've went down from 0 to 1, from 1 to 3, and then 3 to 4. That was the path we found. And then all these other edges are what we call back edges, which are ways to go to quickly back up the tree, right? That would back us up to a node where we've already seen it. And that is something you'll learn more about in algorithms. So depth first search, the algorithm for that is something you already know. Mark the node visited, enter it in the discovery order list, and then for everything adjacent, if you haven't seen it yet, go to there and recursively do depth first search. Or you can just use a stack. Again, we're going to look at every single edge twice, right? So in this case, it's O of E. And then also you have this, you have to mark all the nodes as unvisited initially, so that's O of V as well. So total time is marking all the vertices as unvisited initially, and then O of E. I mean, I suppose you don't have to do that as well. So that's so for your homework, you're going to be implementing. Your first homework will be to get Jung running is implementing a depth first search and a breadth first search.